We're going to talk about question 5 from the differential equation worksheet. So this is asking for the particular solution. And this equation is y prime equals y squared over x cubed. And our initial condition is y equals 2 when x equals 1. So our very first step would be to group our variables, but my variables aren't clear right now because my notation has y prime is y squared over x cubed. So I don't know where my dy and my dx is unless I rewrite unless I rewrite y prime as dy dx because they mean the exact same thing. So I'm going to rewrite my y prime as dy dx. They both mean the first derivative of something, but this one tells me with respect, and this one gives me more information, so it's the one I'm going to want to use here. Once I write it out, my next step is to group my variables. In this case, the way that this is written, it can be confusing to see what needs to go where. So one of the things that you can do to start this off to make it more clear is to go ahead and cross multiply. Even though these both aren't y's and these both aren't x's, sometimes it can make it more obvious what your next step should be to group your variables. So let's go ahead and do that just so we can have a very clear picture of how to get all my y's on one side and all my x's on the other. So if I cross multiply, I end up with y squared dx equals x cubed dy. Now I know that my dy and my dx can't be in the bottom of a fraction. So this guy is stuck and this guy is stuck. They need to be in the top because 1 over dx and 1 over dy don't mean anything. So what I have the option to move are my x cubed and my y squared. So I can divide both sides by x cubed to get it away from this dy. It'll end up down here. And I can divide both sides by y squared and it'll end up down here. So let's go ahead and do that. I'm going to divide both sides by my x cubed. I'm going to end up with dx over x cubed. And I'll divide both sides by my y squared. So I'll end up with dy over y squared. Now, it would have been possible to see this from this step. So I want to go back just for a second to show you how you could have seen that. We do want to get this dx on the top, so we would multiply both sides by dx, and it would put it up here next to this y squared, which is exactly where it ended up, with the x cubed on the bottom. And then to get the y squared away from the top of a fraction, we do need to divide both sides by y squared. So if we divide both sides by y squared, it'll end up on the bottom under this dy. So you could have done that in the same step, multiply by dx and divide by y squared, instead of cross-multiplying then dividing. But the process that you use is really whatever you're most comfortable with. So stick to what you know. If it's easier to just cross-multiply to get rid of the fractions, then move things, that's fine. Please do that, whatever is most comfortable for you. Okay, now we have everything grouped, and we can go ahead and write that we want to take our integrals. But we don't have a quotient rule for integrating, so it actually is easier to integrate these if I rewrite these functions one more time. And the way that I want to do that is I want to take these variables that are on the bottom and I want to move them to the top so that I won't have quotients anymore. And the way that I do that is by moving the whole variable up with its exponent, and I just make its exponent negative. So this is going to be the integral, except it's going to be x to the negative 3 power when it's moved to the top, and my dx will be beside it. And then I'll do the same thing with my y squared. It'll stay y squared, but the 2 will become negative to show it used to be in the bottom, and then I can put my dy after. Now I can see that all I have to do is use my power rule that I know for integrals to integrate each one of these guys. So when I integrate this one, I'm going to add 1 to the exponent, but its exponent is negative. So when I add 1, it actually becomes negative 2, and I have to divide by that new exponent, divide by negative 2. Now on the right, I'm going to do the same thing here. Add 1. This is going to become y to the negative 1, and it's going to be over negative 1. And I'm going to have a plus c on the end. I'm going to simplify these before I start working with my initial condition. So over here, This negative 2 can stay on the bottom, but my x squared is going to come back down to the bottom. The negative means it should be on the bottom, just like it was up here. So I'm going to move it back down to the bottom. And the only thing I'm going to do to simplify this is there's going to be a 1 left over holding the place of the top variable. So I'm going to move the negative just to live with that 1 on top instead of being on the bottom, because it's going to be a bit crowded on the bottom. So we have a 1 left over from my x squared. The negative is from the denominator. And left over in the denominator, I'm going to have my 2, my x, and my squared, which is going to become positive again because I just moved it back where it belongs. On the right, we're going to do the same thing. I'm going to put my negative sign in the top. When I move my y to the negative 1 back down to the bottom, I need a 1 there as a placeholder. So I end up with a negative 1 over, and this y to the first power that's going to go back to the bottom, I can just write that as y. I don't have to write the first exponent on there because it's implied. If you don't write it, then they're going to know that you mean the first power. And then I'll put my plus c on the end. Now to get my particular solution, I need to use the initial condition that they gave me. So that initial condition is that y is 2 and x is 1. So everywhere I see x over here, I'm going to plug in the number 1. And on the right, when I see the number y, I'm going to plug in the number 2. And what I'm actually going to find here when I simplify this is negative 1 over 2 times 1. So this is negative 1/2. And this is negative 1/2. So negative 1/2 equals negative 1/2 plus c. So when I add 1/2 to both sides to get this away from c, this actually disappears because negative 1/2 plus 1/2 is 0. So c is 0, which is great because I'm almost ready to find my particular solution. All I have to do is plug the c back in to the form that I used before I plugged in my points. So that would be this form right here. So I'm going to write it over here on the side. Negative 1 over 2x squared equals negative 1 over y. And then I could write my plus 0, but it's just extra information that doesn't change anything. So I don't even have to write my plus 0. This is almost my particular solution. The only other things that I can do here is I can recognize that I have a negative number on the left and a negative number on the right. So I can multiply both sides by negative 1 to get rid of those negative signs. Or I could divide both sides by negative 1 to get rid of those negative signs. Or I could just change every single sign in this problem. It will do the exact same math for me, just a little bit faster. So I end up having a positive here and a positive there. Once I'm done with that, I have one more step. And there are a lot of different ways that I can go about this. I can cross multiply here to get my y out of the bottom. I would do y times 1 and 2x squared times 1. That would work. I can also just see that if I have these two things that are equal and they're both 1 over, I can basically just flip them both upside down and they'll still be true. So I can just take this 2x squared and put it on top and take this y and put it on the top, and those things will be equal to each other. Whatever process you want to use, it will get you to the same place. So if the jump and flip is too much to kind of take in, then we can just cross multiply. That's just as easy. So y times 1 is just y, 2x squared times 1 is 2x squared. And what we basically just did is we took the 1 over and turned it into over 1. So the over 1 is invisible now. And this is our final particular solution for this problem. We're going to go ahead and work on number 6 in the next video.